In this presentation, we'll be looking at the basic chemistry concepts behind some of the most popular heroes in the Marvel Cinematic Universe, or MCU. Nearly everyone knows and loves these movies, but have you ever wondered how the science fiction in these super-powered flicks stacks up to the science fact? Let's start with the old-timer Avenger, Captain America. Old Cap wouldn't be him without the super soldier serum. The serum is a substance that, coupled with special wavelengths of light known as Vita rays, physically transforms frail all-American boy Steve Rogers into the buff Captain America. In the MCU, Steve Rogers is the only one we know so far to have been given this treatment, and so far, its effects have seemed to be permanent. It gives Cap his strength, speed, agility, endurance, and slows his aging because of how it increases his metabolism. To state the obvious, there is nothing like this in real life. Scientists have established what genes are involved in the increase in muscle mass and the improvement of the blood's ability to carry oxygen, but have not applied this knowledge towards any such serum. They've also developed epigenetics, which allows for individual genes to be turned on and off using special tools. In theory, these tools, such as zinc finger nucleuses or CRISPR systems, could let scientists turn on the genes that make your muscles bigger or better your stamina. Now on to his shield. This is vibranium as seen in the MCU so far. We might all know what it looks like, but how much do we know about it? We've seen this metal a number of times in the MCU. It's appeared in Iron Man as an Easter egg. It's what Tony Stark purportedly creates from scratch in Iron Man 2 with his DIY particle accelerator. It's what Cap's famous shield is made from in both Captain America movies to date, and through being attached to both Iron Man and Cap, it's appeared in the Avengers movie. Clearly, vibranium is important to the MCU, but what is it? Vibranium is a fictional metal in both the MCU and in the Marvel Comics universe, Earth 616. It comes from the, again, fictional African country of Wakanda, which is ruled by the Black Panther, a coming-soon player in the MCU. Listen up, because vibranium isn't going anywhere anytime soon in the MCU. With the announcement of Black Panther movie, the element might very well take center stage in the next few years. Vibranium, like many good sci-fi concepts, comes from space and only has two isotopes, one of which is a complicated antimetal that has yet to factor in the MCU, so for everyone's sake, we'll be focusing on the main Wakandan isotope. This isotope is an energy-absorbing machine. It not only absorbs energy, but can store it and then release it. Kind of like a battery, the more charged with energy vibranium is, the harder it is to destroy. It can also emit radiation capable of mutating organic matter, though this property has not been shown in any of the movies so far. It has a number of potential uses based on its unique properties, but does anything like this exist in real life? Though fictional, vibranium does share some core similarities with real materials. Vibranium came from space in a meteorite, which is how quite a few elements found on Earth came to be. Some accessible precious metals came to our newborn Earth in a barrage of meteorites, and these metals then were able to set up shop on our planet. Why accessible metals? Because though there is a lot of gold deep within our planet's core, there is no way for us to drill that deep into the core to reach it. So all of the gold currently used in jewelry, technology, manufacturing, the like originated from meteorites. Additionally, phosphorus is considered to have likely come from meteors that hit our helpless baby planet, and that element helped with the development of life on Earth. As for vibranium's strength and cutting ability, one of the hardest minerals in real life, lonsdaleite, forms when meteorites hit the Earth. This extraterrestrial origin might support why vibranium is so much stronger than the average metal. And being a metal, vibranium shares the same basic physical properties as brethren. It's shiny, hard, and can be reshaped and even recolored using sufficient energy and technology. As for its iconic absorptive power, vibranium stands unmatched. There are no perfectly parallel elements that share its skills. There are, however, phase change materials, or PCMs, which can absorb and release heat, a form of energy, without getting hotter themselves. This is similar to how vibranium's physical properties don't change when it absorbs energy. To illustrate how PCMs work, imagine melting a pan of ice cubes over a gas burner. The ice cubes will melt, undergoing a phase change from a solid to a liquid, but the melting ice in the pan will stay consistently cold until all of it is melted. It's only once that the water has went from solid to liquid completely that it feels warmer to the touch. There are many materials classified as PCMs on Earth with a number of different uses. Where the average non-scientist person is concerned, we might run into PCMs on a daily basis by using freezer gel packs in our lunches, which consist of water and the PCMs propylene glycol and sodium carboxymethyl cellulose. The PCMs allow the pack to absorb the heat of room temperatures without becoming so hot that they melt, allowing your food to stay nice and fresh throughout the day. In conclusion, there is no real-life metal both hard enough to cut through metal and soft enough to absorb that much shock. Vibranium is not real, and even if something like it were to be synthesized, that artificial alloy made from both hard and absorptive materials would end up having average properties, as the hard and absorptive properties would negate each other. But, oh my stars and garters, does it look good in motion. From Cap's shield to Thor's hammer, we move to the next fictional metal that plays a big part in the MCU, Uru. Uru is a metal from the dimension of Asgard, which is featured heavily in both Thor installments as Thor's homeland. Thor's hammer, known as Mjolnir, is made from this magical metal. Like vibranium, it can store energy, but for a far longer relative period of time. In the case of Thor, it can even store magic, and its durability increases with the amount of magic it has stored away inside. It is a strong, strong metal that can really only be forged into weapons through extraordinary means, such as using the heart of a star. It cannot be hammered into thin sheets and has never been shown being pulled into wire. On the left is Uru as seen in Thor's hammer in the comics. On the right is Uru as seen in the movies. The movie Mjolnir has a more conventionally metallic appearance with a luster and finish similar to that of refined brushed steel rather than stone or cracked iron. Mjolnir is Thor's trusty hammer. It's made from Uru, enchanted, and its powers are encrypted to those it considers worthy of having such power. When Thor throws it, it behaves like a boomerang, as it, when thrown, will come back around to where it was thrown from, and when summoned by Thor, it will always return to precisely where he is, as if it were magnetically attracted to him. It can create nasty storms and open up portals into other dimensions. So far, Thor is the only person in the MCU who has been able to wield it. Accordingly, this means that he is the only person regarded as worthy enough by Mjolnir. In this bit from the upcoming Avengers sequel, Age of Ultron, Iron Man himself can't even nudge it, for it doesn't consider him worthy. He even goes so far as to get his buddy Rhodey with his Iron Patriot gauntlet on to try and lift it with them, and it still doesn't work. The only Avenger who manages to budge it even a little is Captain America. Uru seems to physically resemble the properties of real-life metals. Like a metal, it is obviously a great conductor of electricity, allowing Thor to bring the thunder. In the movies, it appears shiny like a brushed metal. It's also very dense and solid at room temperature. Like a non-metal, it cannot be hammered easily, it cannot be made into wire, and because we can see the blue lightning or magical energy crackling within it, it may be transparent as a thin sheet, and only appear to be so opaque because of the density of its layers. Because it looks and behaves more like a metal than not, if it were real, it would most likely be considered a metal, and because of its high density, melting point, hardness, durability, color, seeming magnetic properties, and conductivity, it would most likely be considered a transition metal. Moving on to this guy, Tony Stark, genius, billionaire, playboy, philanthropist, and Iron Man. Despite his name, Iron Man's armor isn't made from iron. It couldn't be because of how dense, heavy, prone to rusting, and comparatively weak it is. His first armor, the Mark I, most likely used some iron or iron components out of a lack of other resources available, but his pretty, shiny, sleek armors are iron-free. It's never openly stated in the movies what his suits are made from in detail, but it's speculated that they can be made from a variety of different materials, such as nitinol or nickel titanium, which is an alloy of titanium that is relatively light, strong, highly resistant to heat, and can be repaired fairly easily. Carbon-carbon composite, which is a kind of carbon fiber reinforced graphite, is very strong and can withstand a lot of heat, but is brittle. It's likely that, because of its ability to take a lot of heat, Tony uses these in his rocket boots, because in real life, the composite is used for the nose cones of space shuttles, which can be exposed to temperatures above 2,300 degrees Fahrenheit upon re-entry. Single crystal titanium is a specialized form of titanium that makes it far stronger than other titanium types. It's used in military jet engines, and if it's used by the military, then Tony Stark, former industrialist and brilliant engineer, probably uses it too. Until Iron Man 3, the arc reactor embedded in Tony's chest prevented shrapnel from reaching his heart and powered his suits. This reactor is likely based upon the tokamak reactor from the Cold War-era Soviet Union. It's not as tiny as Tony's reactor, but it does have the same basic donut shape, uses magnetic fields, which are what keep the ferrous shrapnel from reaching Tony's heart, and also uses plasma to generate a lot of energy. The arc reactor is basically a little nuclear reactor in his chest, and the notable use of palladium in powering his suit up until Iron Man 2 could mean that the reactor uses the cold fusion process, which is nuclear fusion that can happen at close to room temperature. And for it to be directly in Tony's chest, it would make sense that the reactor not burn too hot. Here's what a real-life tokamak looks like. This is the tokamak fusion test reactor at Princeton University, and as you can see, it's not very compact. The palladium at the core of Tony's arc reactor becomes an issue in Iron Man 2. As it turns out, it's slowly killing him. Could that really happen? Palladium is a precious transition metal in the platinum family. Tony uses it to help power the reactor through the cold fusion process, which is yet to be done in real life anywhere near how Tony's managed to use it. Theoretically, palladium would be used in that process, along with the hydrogen isotope deuterium. The metal poisons him, which motivates him to create another option for his arc reactor, the metal vibranium. Of course, it is implausible for him to have created a stable element in the course of an afternoon as shown in Iron Man 2, just as unrealistic as the depiction of palladium as a lethal element. It has a low toxicity, so it wouldn't poison someone like that. It has a number of uses in real life, from cars and dentistry to jewelry and hydrogen purification, and is similar to platinum in its properties and appearance. Because of its rarity and appeal, it is fairly expensive. Of course, for a billionaire like Tony Stark, money is no object. On to the Hulk. Fun fact, this is how I feel every weekday morning upon waking. So, for the uninitiated, the basic premise of the Hulk is this. Bruce Banner, a acclaimed physicist, accidentally gets caught in a massive gamma-ray explosion. He somehow survives the exposure to the otherwise lethal dose and type of radiation, but the radiation does change him, and whenever he gets angry enough, he turns into the Hulk. This is all due to gamma radiation. If DNA is exposed to this type of radiation, its helix can break in a process called chromothripsis. The body can repair a few of these breaks and be fine, but if a lot of these breaks happen, as would be the case with Dr. Banner, then the body can't correctly repair all the damage done. New instructions would then be put into the genetic code as a result. When Bruce's DNA reassembled after the accident, it likely included new epigenetic switches, and these switches are activated by the hormones in his body that are produced whenever he gets angry. As for the Hulk's skin, it could be green because of the trauma from the accident. If you've ever gotten a bad bruise, you'll have noticed that they can sometimes look kind of green. This is because when you get a bruise, the injured red blood cells die and the molecules on their surface, hemoglobin, start to dissolve. When it dissolves, one of its metabolites, a molecule known as biliverdin, can make the blood look green. Perhaps the Hulk's powers are the result of his blood being full of a new type of molecule that is green and works better at carrying oxygen than hemoglobin, giving him better strength and stamina than the average man. Still, though it sounds plausible, in real life, if you were in such an accident, you would almost certainly die instantly. To wrap it all up, the MCU is awesome. We know that. Evidently, their scientific accuracy isn't as on point as their movies because you can't get powers from serum or radiation, and actual metals can't do what vibranium and Uru can. Even though the details are factually shaky, Iron Man is the scientific standout of this group. His armor is plausible, and his reactor tech is based on real-life concepts that, with some creative license and Stark genius, could be taken to the superhero level. Still, the MCU is doing just fine otherwise. These movies make billions of dollars worldwide, so the world probably doesn't care too much that such liberties are being taken. Mark your calendars for the next wave of Marvel Studios movies, starting with next year's Avengers Age of Ultron in May 2015, all the way to the fourth Avengers movie in May 2019. 4 more years with lots of science and sci-fi themes sure to come up. Also, magic. See you at the movies!